Let's do question 3. Question 3 is asking, what do you understand by the term abstract class in Java? Let's answer this the same way we've answered the rest. Let's create a class called abstract. So what do you understand by an abstract class? An abstract class is an incomplete class that cannot be instantiated. That's the definition of an abstract class. 2 marks. Part B, explain why an abstract class cannot be instantiated. Why? Why can't we instantiate an abstract class? So basically, if this class was abstract like this, why can't we do something like abstract? Oh, that's a keyword. Object equals new abstract. Why can't we do something like this? Because when I hover over this, it will say this class is abstract. We cannot instantiate it. So why can't we instantiate an abstract class? Well, the answer is closer than you think. Because an abstract class is incomplete. So you can't create a house from an incomplete blueprint. You know those blueprints that architects use to build houses. So you can't have an incomplete blueprint and use it to build a full house, which would in this case be an object. So if a class is incomplete, then we can't use it to build any objects. We can't use it to construct any objects. Remember, a class is a blueprint. In Java, class is a blueprint. Class is a blueprint. And if you have an incomplete blueprint, you can't use it to create any objects. So the answer becomes you cannot create objects from an incomplete class, which is an abstract class. Oh, okay. Let's just say, let's use that one. You cannot create objects from an incomplete class. That becomes our reason for why we can't instantiate abstract classes. But see, write down 2 ways how a class becomes abstract. 2 ways. How can a class become abstract? Well, we've seen here this class can become abstract by using this keyword abstract. So the first way is going to be making the class abstract using the keyword abstract in its declaration or definition. Declaration. The second way a class can become abstract. So if we didn't do this, this is now a concrete class, a complete class. So if we didn't do this, what's another way to make this class abstract? Well, we can declare, by declaring, this is the second way, by declaring abstract methods within the class. because when we do something like this, when we declare abstract methods within the class, so if I go ahead and say public, create an abstract method, abstract void called it, like that. Remember how we create abstract methods? We don't give them a body, we just stop there. So if I have an abstract method within a concrete class or a complete class, this will force this class to become abstract so that we can accommodate this abstract method. So to make this error go away, we need to make the class abstract like that. That's the second way. So we can you can just stop here and get the 4 marks. Or we can see another way. Another way it could be, let me go down here and say I have a class called X, like this. It's a concrete class, but I want to make this class abstract. So I can do so by extending another abstract class, which in our case is abstract, because this abstract class is abstract. So if I extend an abstract class, then this X also becomes what? It is forced to become abstract unless we override, or unless we implement these abstract methods within what? Within this class. So I can make this class abstract by just including the keyword like that. What's happening there? Class abstract extends abstract identifier expected. Oh, wow. Okay, the keyword comes first. So you say abstract class like that. So you're forcing this class to become abstract by extending an abstract class. So that could be the third way, by extending an abstract class and not implementing. That's a key thing to do, and not implementing any abstract methods. So let me explain this, not implementing any abstract methods. Because when you extend an abstract class, you're forced to do two things. Either mark that subclass as abstract, or you are forced to you're forced to implement any abstract methods within this abstract class you've extended, and we only have one, which is it. So if I override the it method like that, then the class becomes what? Concrete. It becomes complete. It's now a complete class. It's no longer abstract. So you must not implement this so that you can force that class to become abstract. So those are the 3 ways I know. Which maybe we could also, if I have a class down here, a class called Y, a concrete class like that, and I have my interface called Z, and this interface has an abstract method. So a public abstract void run, like that. So I could make this class abstract by implementing the interface like that, which will force it to either implement this like we did here, either implement or make it abstract like that. That does not work. Why? Cyclic inheritance involving Y. Oh, oh, we're implementing Z, sorry. Boom. So if you don't make the class abstract, you are forced to override the abstract method within the interface Z. So if you choose to override, then the class becomes what? Concrete. Or since what we want is to make the class abstract, we do that. And then it becomes abstract. So a fourth way could be by implementing an interface with any abstract methods and not implementing those abstract, that's a long one, methods. So you either implement an interface, and that interface must have abstract methods, and not implementing those abstract methods, because when you don't implement them, then you must make the class what? Abstract for the code to compile. So those are your 4 ways. Let's put this into view like that. Those are your 4 ways, but they ask for 2. Write down 2 ways. I've given you 4. Let's go to part C. That's where we were. Part D. Using an example of your choice, demonstrate polymorphism. What is polymorphism? Polymorphism is the ability of an object to behave differently depending on its environment. So we need to demonstrate that by using an interface and a class. So let's go here. Let's make this, comment it out so our code runs when we start writing some code here. So what are we demonstrating? Polymorphism. Let's call that poly. A new class called poly to demonstrate polymorphism. And they want us to use a class and an interface. We can use interfaces like this. So we have an interface called, what should we call it? H. So I have a class, interface, and they want us to use polymorphism. So this interface of ours is going to have a public void. This method is abstract. It's going to be called run, like that. And then this class, of course, is going to implement the interface H. And by implementing the interface H, we need to override the run method, like that. So how do we demonstrate polymorphism? Let's first make this print something out. Let's say this runs. So now we need to create objects. So let me come here in our main method, create objects of type poly. Call this object 1 equals new poly, like that, and object 1 runs, or rather calls the method run. So if I run this, it should print this runs. So I have this runs there. Let's move that there. and they are saying your interface must have a method. Your interface must have a method and a constant, and your class should implement this interface. So let's give this interface a constant as well. Constants in interfaces are always public, static, and final. And our interface is going to be an integer called age. And if it's final, then I have to initialize it right away. Let me give it an age of 29. So this is our constant. And this is our method, our abstract method. And your class should implement this interface and use the interface's constant. So we must use this constant in our class here. How am I going to use the constant? I can say I can just print out something like I am. To access this constant, I need to use the interface name h, not the object this time. I need to use the interface name h dot age, like that. So now you see we have accessed this constant. As you can see here, we have one usage IntelliJ is saying. So we have accessed the constant, and we have overridden the method, provided an implementation for it. And that's it. I believe that's it. Okay. So this is polymorphism. Is it? Let's confirm. Let's do a quick search. What is polymorphism in Java? So a task that performs a single action in different ways. So something that does something in different ways, like we had defined earlier. An object that behaves differently based on the environment it is in. That is polymorphism. So in this class, in this environment where the class is poly, in this environment, this object here, not the object, this method is going to behave like this. So if we had, but they didn't ask us for this, but say we had another class R, which also implemented the interface H. And this class R would also need to override what? That method, this method here. And by overriding that method, you're going to have to provide your own implementation or another implementation of this method. So in this context, in this environment, this method was running. So here in this context, in this environment, this method is going to be implemented in a different way. So it's going to say something like, I run every day. Meaning, if we have a main method down here, and we created an object of type R, and this object used the run method. So we have the same method here, defined in the declared in the interface. They have the same method, but its implementation is what is different depending on the environment, on the context. So here it will say I run every day instead of this runs. So you have one thing behaving differently based on its environment, and that becomes polymorphism. So we have I run every day instead of this runs. Okay. But they didn't say use two classes. They just said use an interface and a class. An interface and a class. So by just stopping here, you would have answered the question. So that's what you needed. This was just extra stuff to further explain polymorphism. Okay, so that's question 3.